Now let's look at how we sketch logarithmic functions. We have here, I've already given you the picture, and this is power of 2, or a base of 2 rather, the number x. We don't know the power, but the x is just going to be the different numbers. This is the inverse of an exponential function with 2 being the base. It would look like this. If you remember, it would be a growth function. It would come up like this and hit the point 0, 1, which I guess these are counting by 2, so 0, 1 would be right here. So because it's the inverse, notice that this hits at, instead of 0, 1, it hits at 1, 0 there. So if I want to talk about the domain, you have mentioned this a little bit. The values would be from, we cannot equal 0, so it starts after 0, and it goes on to positive infinity. We do have an asymptote here, so I'm going to add in a little asymptote here. It would be at y equals 0 like that. Not y equals 0, I'm sorry. This is at x equals 0 that we have an asymptote. So the domain is from 0 to infinity, or you could write this as that 0 is less than x. The range, this graph goes down forever and up forever. So you'd say from negative infinity to positive infinity, or you could say that y is an element of the reals. As far as the intercepts go, it does not cross the y-axis, but it does cross the x-axis. So we have an x-intercept at 1, 0. I mentioned asymptote. We have a vertical asymptote. At x equals 0. If we wanted to write the end behavior, I'm going to say that the limit of f of x as x approaches negative infinity does not exist. It doesn't exist going left, but it does approach 0. It's approaching 0 from the right side. As we approach it from the right side, we would say it goes down to negative infinity. This would not necessarily, in behavior, just talking about the far left and far right. I'll just write it that way for now. You'd have that limit, and you would also have the limit, though, as it goes to the right. As we go to the right, this graph goes up to positive infinity, and the graph is always increasing on domain. It's always going up over time, so it's increasing on its domain. Okay, now let's look at this. What happens when my base becomes 1/3? This would be kind of like a decay function from earlier. Now we have this graph, but now instead of it going up over time, it goes down because the base is 1/3. So basically, almost all of this stays the same. There's only going to be a few things that change. So I'm just going to copy this real quick. And the things that will change that you might want to take note of is, let's see here. Domain is the same. It hasn't changed. The asymptote hasn't changed either. We can see the asymptote is still there. That's not different. But what seems to have changed is it's not increasing on its domain. It's decreasing on the domain, so we can change that. So we'd say decreasing on domain. And the limits have changed. It's no longer going down as it approaches 0 from the right side, or going up as we go to the right. Now we would say, as I approach 0 from the right side, it's going to positive infinity. As I approach the right, it's going down to negative infinity. All this seems to be the same. We still have this y-intercept at 1, 0. Excuse me, x-intercept. The range is the same, domain is the same. Now you can try to describe this one.